after the red giant or red supergiant is supernova, right? Because red giant or red supergiant is in that stage where the temperature of the core of the star is large enough and explodes, and that the core of the star explodes and it's in the form of the supernova. So this explosion blows the outer layers of the star into space. Okay? Then the remaining core of the star contracts and may form an extremely dense neutron star, or even the star with high mass or high mass star can even ends in a black hole. So this is the last stage of or the form of the death of a star is in the neutron star or even a black hole. So that depends on the mass of the star. Supermassive star dies in the form of black hole, and high mass star is usually dies in the form of neutron star. So this is the last stage. So here is just a brief idea about the black holes. We can talk about the black holes that are very small and very dense, and this is the massive concentrations of matter where the gravitational pull is used. Even the light cannot escape from the gravity of black hole. So actually these are the stages of the life camp of a star, from the formation of a star and the ends of a star. So we can just make a summary to keep it in mind about the different stages of a star. So I'm going to write the different stages of a star. So we can summarize the life history of a star. Like this. So the first stage, that is a huge hydrogen gas cloud in space. Hydrogen gas cloud in space. We know that the first stage of a star is in nebula, right? And this is nothing but the combination of gas and gas particles like hydrogen gas. So the first stage, that is, we used to say, that is nebula, and that nebula is then turned into the stage that is called protostar, right? And what happens in protostar, you know that gravity pulls gas cloud together making a protostar. This is the second stage. Gravity pulls gas cloud together making a protostar. And first stage, that is actually called nebula. The second stage, which is a photosphere. Then what happens? That is the high pressures and temperatures, cause the nuclear fusion. Nuclear fusion of hydrogen. So in the stage of photostar, nuclear fission of hydrogen starts, and that happens due to high pressure and temperature, which is actually due to the force of gravity, because the kinetic energy, gravitational energy of hydrogen gas particles is converted into kinetic energy, and that's why inside the photostar or in between the gas molecules or atoms, high pressure and temperatures start to work to cause the nuclear fusion of hydrogen, And this is the longest stable period of normal life. Long stable period of normal life. This is called main sequence, right? Main sequence stage. This is the main sequence stage. Okay? The first nebula, second is photostat, and in third stage that is main sequence stage, where the nuclear fusion of hydrogen continues. So in the main sequence stage, here energy is released by fusion of hydrogen to helium. For a very long time, for many millions of years, the main sequence stage continues for many millions of years. So after that, hydrogen runs out. In the main sequence stage. When all hydrogen gas runs out in main sequence stage, then the fusion of helium starts. Hydrogen runs out in helium in main sequence stage, and next stage depends on the mass of the star. So here we'll talk about the mass of a star. So So that is first, that is medium mass star. We have to talk about what happens to the medium mass star like Sun, medium mass star. Example Sun. And high mass star. That is few times larger than the mass of Sun. That is few times more massive than Sun. This is the high mass star. K is infusing. K is fusing helium to other elements. K is fusing helium to other elements like carbon. Like carbon, and that is super heavy star. Super heavy star. Many times more massive than our Sun. Many times, not few times, many times more massive than Sun. This is super heavy star. That is super heavy star. So what happens? Let's see. Medium mass star like Sun that turns into red giant, right? That is outer part of a star becomes outer part of the star becomes cooler and forms a red giant. This is the medium mass star. It is turning into a stage of red giant after the main sequence stage. But what happens in case of high mass star, which is few times more massive than our Sun? So that star forms a red supergiant. That is high mass star forms a red supergiant. This is the red supergiant. High mass star is turning into a red supergiant. Okay. Then explodes, forms a red supergiant, then explodes forming a supernova. And medium mass star that forms a red giant after the mentioned stage whose core is for shrinks to form a white dwarf. White dwarf. Okay, this is the medium mass star like sun. So, what's the end of our sun? We'll say that is the white dwarf, right? When our sun flashes, it will be converted into a white dwarf, right? It will turn into a white dwarf stage. That is the last stage of our sun. But high mass star that is forming a red supergiant, and when the red supergiant explodes, that is forming a supernova stage. And the supernova stage, after explosion in the form of supernova stage, its core contracts to form a neutron star, to form a neutron star. So this is the end of a high mass star in the form of a neutron star. Now this is super heavy star, which is many times more massive than our sun. So what happens? This star forms red supergiant, okay, then explodes as a supernova, okay, forming explodes, okay, then explodes forming a supernova, and this supernova, core of the supernova core contracts to form a black hole. So these are the stages of a star with different masses. Medium mass star, high mass star, and super heavy star. So medium mass star is our sun, and high mass star, which is few times more massive than our sun. Okay, and super heavy star, which is many times more massive than our sun. So we could see the end of stars with different mass. So medium mass star that ends in the form of white dwarf. That is the last stage of medium mass star. Okay. So if we summarize, after the main sequence stage, what will be the next stage of the star that depends on their mass. So medium mass star is forming a red giant, or medium mass star enters a red giant stage after the main sequence, while high mass star enters into a red supergiant after the main sequence, and even super heavy star enters into the stage of red supergiant after the main sequence stage. So high mass star and super heavy star both are entering in the same stage, that is the red supergiant after the main sequence. Okay. After the main sequence, after this red giant or red supergiant stage, what happens to the next stage? Which is that medium mass star that enters into the last stage after the red giant, and it is white dwarf. Whereas high mass star after the end of red supergiant, it enters into a supernova. After the stage it explodes, high mass star and also super heavy star explode, forming a supernova stage. And the core of this remaining, that is the supernova, core of the supernova, that is contracts in to form a neutron star. That happens for the high mass star. But that supernova, that means the core of the supernova contracts to form black hole. That happens in case of super heavy star. That is the super heavy star. So here is the variations. That means finally in the last stage, high mass star and super heavy star differ in the last stage. High mass star ends in the stage of neutron star, whereas the super heavy star ends the stage of black hole. Okay? And the stage prior to that is the same, that is the supernova stage. Okay, that is formed after the same stage, that is the red supergiant for both high mass star and super heavy star. I think it's all about the lifetime or different stages of a star, and this knowledge is adequate whatever I think about this evolution of a star for Edexcel O level physics. Okay, thank you everyone. Bye.